When considering the period, the phase shift, and all the other jazz about trig functions, you might see the standard form of sine in a few different ways. But one way of considering it is like this, where A is the number multiplying the sine. That dictates your amplitude. B affects the period of your graph, which represents how long it takes until you start completing another loop of the sine function, another iteration of the sine wave. And plus, the C over here represents the phase shift, how much you go left or how much you go right from the origin. And the plus D on the outside tells you how much you go vertically from the origin. Plus 4 would mean you go 4 up. Minus 4 would mean you go 4 down from the origin. So using that, our B is 2, our A is 1, and our D is -1. Our C is nothing. There's nothing to be found there, so our C is 0. So let's use that stuff to answer their questions. First, the period of a function. Using this notation that I've given, the period of a sine or cosine function is 2 pi over b. For just a note, for if you're using tangent right now, it should be pi over b. In this case, our b is 2. So if we plug that into our period function, 2 pi over 2 gives us a period of 2 in our case. For our problem, the period is 2. It starts repeating itself after 2 units. The phase shift is always dictated by C, or the amount you add or subtract inside the trig function. There's nothing here, so our phase shift is going to be 0 for this problem. And the range, we can find that one after we sketch a graph. So we said there's no phase shift, which means we don't change sign, we don't move sign to the left or to the right from where it originally starts. But there is a vertical shift. Subtracting 1 means that sine doesn't start at the origin and then go up and down and up and down. Instead, it goes down one space and then goes up and down and up and down. We can do the reverse over here. Okay, and that's all because of that -1. It shifted us down one space. And notice how I stopped my peak rate at 0, because the amplitude of this function is dictated by A, the number in front of sine, and that's 1. So that means I can go 1 up from my starting point, and I can go 1 down from my starting point. So this is a rough sketch of the graph, and a period occurs when you start repeating yourself. So here's the start of the graph, and we repeat ourselves starting at this point over here. So I've stretched it out a little bit too much because we just said the period's supposed to be 2. I mean, that makes it work right there, but it kind of looks like a graph that's not well to scale. But again, the period piece represents how many units you have to go before you start repeating the graph. And that's where we start repeating, right there at 2. We solved that by using the little period formula that we had there. So there we go. The last step was the range. Range of any function is how low your y values can go to how high your y values can go. We can go as low as -2 inclusive. We can go as high as 0 inclusive. That's the range. Because I just looked at what the lowest y value can have. This is -1. Since our amplitude was 1, that means we could go down to -2. We could go up to 0, -2, up to 0. So our total range of y values is -2 to 0.